Good morning. This is our Balaji. Today we discuss our Unit 3 topic, Ultrasonics. In this topic, first we discuss introduction, properties of ultrasonics, production of ultrasonics, detection of ultrasonics, and applications of ultrasonics. Now, introduction. Generally, the audible sound waves frequency lies in between 20 Hz to 20 kHz. Sound waves having frequency greater than 20 kHz are called ultrasonic waves. Sound waves of frequency less than 20 Hz are called infrasonic waves. In nature, bats can produce and detect the ultrasonic waves. Ultrasonic waves are having high frequency compared to the audible sound, so they have highly energetic. And the wavelength of ultrasonic waves is less than the wavelength of the audible sound waves. So, ultrasonic waves shows negligible diffraction due to their small wavelength. When the intense ultrasonic radiation passes through the liquid, it causes bubbles to be formed. This effect is called disruptive effect. Production of ultrasonic waves. Generally, to produce the ultrasonic waves, we have various methods, which are Galston whistle, magnetostriction generator, crystal transducers. Now, first here we discuss about magnetostriction method. It is very important topic for examination purpose. So, in the magnetostriction method, the principle is when a magnetic field is applied parallel to the length of a ferromagnetic rod made of materials such as iron or nickel, a small elongation or contraction occurs in its length. This phenomena is known as magnetostriction. The change in length depends on intensity of the applied magnetic field and the nature of the magnetic material, and it is independent of the direction of the field. This is the principle of magnetostriction method. When the rod is placed inside the magnetic coil carrying alternating current, the rod suffers a change in length for each off cycle of alternating current. It means that the rod vibrates with frequency twice that of the frequency of alternating current. The rod vibrates with frequency is equal to its natural frequency, the resonance occurs. The natural frequency of vibration of the rod is given by Y is equal to 1 by 2L Y by rho, where L is resonating length, Y is angular modulus of the material, rho is density of the rod. If the frequency of alternating current is sufficiently high, ultrasonic waves are produced from the ends of the rod. Frequencies ranging from a few hundred Hz to about 300 kHz can be produced. Now, the construction of magnetostriction oscillator. The simple tuned oscillator constructed with NPN transistor is shown in figure. This is NPN transistor and the emitter which is making to ground. That's why this such type of amplifiers are called common emitter configuration. And input you are maintaining forward bias and output you are maintaining the reverse bias. Now the collector end is connected to the inductor L and capacitor C, which are connected in parallel. The base emitter junction are connected to another inductor coil L1 and the rod which is placed inside the inductor coils. And the rod so here the rod which is vibrates along the x-axis as well as y-axis. To prevent the vibrations along the y-axis, the rod is clamped at the middle. Now, so the LC circuit is connected to the collector as the rod. The coil L1 is connected to the base emitter and is kept close to L. The ferromagnetic rod is surrounded by L and L1. It is clamped at the middle. Working. When supply is switched on, the collector current starts rising and oscillations starts in the LC circuit. In order to maintain sustained oscillations, change of current in L is feedback to the base emitter circuit through mutual inductance between L and L1. So whenever it is feedbacked to back, then this amplifier circuit is act as a oscillatory circuit. The transistor ensures that the energy is feedback at the correct phase from the battery. The frequency of the oscillation of LC circuit is given by F is equal to 1 by 2 pi root LC. By varying C, this frequency can be adjusted to be in tune with the natural frequency of the rod. Under this resonance condition, sustained oscillations obtained and hence ultrasonic waves are produced by the rod. By adjusting the length of the rod and the capacity of the condenser to obtain different frequencies in this process. What is the advantages with this method? Magnetostrictive materials are easily available and inexpensive. Oscillatory circuit is simple to construct. Large output power can be generated. Disadvantages with this method. Since the elastic constant varies with magnetization, one cannot get single frequency oscillations. Generation of frequencies beyond 300 kHz is not possible. When a single rod of ferromagnetic material is used, a day current losses appear. So this is the magnetostriction method. This is one of the important essay question for examination purpose. The second method is piezoelectric method. Principle. When pressure is applied on mechanical axis of quartz crystal, the potential difference developed along its electrical axis. This effect is known as piezoelectric effect. The converse of piezoelectric effect is also true. According to converse of piezoelectric effect, if alternating voltage is applied on electrical axis, the crystal vibrates along the mechanical axis. Ultrasonic waves are generated based on inverse of piezoelectric effect. The piezoelectric oscillator is as shown in figure. Now, this is NPN transistor and which is connected to the inductor coil and parallel to the capacitor. This is in forward bias and this is in reverse bias, and due to the mutual inductance, the current which is transferred from L2 to L1 and which is connected to base emitter junction. And here another coil inductor, and the inductor one end is connected to A, other end is connected to B. In between these two plates we place the slice of quartz crystal and which is X-cut quartz crystal. Now Q is a thin slice of quartz crystal cut with its opposite faces perpendicular to optic axis. It is X-cut quartz crystal. The crystal Q is placed between two metal plates A and B which act as electrodes. The plates are connected to the coil L2. Coils L, L1, L2 are inductively coupled. Coil L is connected to the collector circuit. Working. When the supply is switched on, collector current starts rising and oscillation starts in LC circuit. In order to maintain sustained oscillations, changes of current in L are feedback to the base emitter circuit through mutual inductance between L and L1. Transistor ensures that the energy is feedback as the correct phase from the battery. The frequency of the oscillator of LC circuit is given by the expression F is equal to 1 by 2 pi root LC. By varying C, the frequency of oscillation of the tank circuit can be adjusted. By transformer action, the electrodes A and B are connected to the coil L2 or induced with alternating EMF. Hence, the crystal Q placed between the electrodes A and B experiences oscillating electric force, and due to inverse piezoelectric effect, high frequency ultrasonic waves are produced. Now, what is the advantages and disadvantages with this piezoelectric method? Advantages. By using this method, you can produce the ultrasonic waves with frequency as high as 500 MHz. Stable single frequency waves can be generated, but it is not possible in magnetostriction method. Using different transducers, one can generate a wide range of frequencies. Now, what are the disadvantages with this piezoelectric effect? Piezoelectric crystals are very expensive. Cutting and shaping are not easy. Now, we discuss detection of ultrasonic waves. Now, the ultrasonic waves are produced due to various methods. Now, how to detect the generated waves, which are ultrasonic waves or some other? To detect the ultrasonic waves, we have three methods: Kunz tube method, flame method, quartz crystal method. Now, first, Kunz tube method. Using Kunz tube method, ultrasonic waves can be detected at the nodes. Lycopodium powder collects in the form of heaps. The distance between the two adjacent heaps being lambda, where lambda is wavelength. In the case of ultrasonic waves, this distance between nodes will be very small. Second one is sensitive flame method. A sensitive flame is moved to the source generated media. Where there are antinodes, the flame is steady. Where there are nodes, the flame flickers because of the change in pressure. Thus, the position of nodes and antinodes can be located. The average distance between the two nodes gives lambda, which is very small if the vibrations are ultrasonics. And last method is quartz crystal method. This method of detection is based on the principle of piezoelectric effect. When one pair of opposite faces of a quartz crystal is exposed to ultrasonic waves, the other pair of opposite faces develop opposite but equal charges. These charges cause potential difference, which can be amplified and detected using electronic circuit. Now here we discuss some bits which are useful for examinations. First bit is the method of detecting the presence, position and direction of motion of distant objects by reflecting a beam of sound waves is known as sonar. Sonar stands for sound navigation and ranging. Wavelength of ultrasonic waves lesser than audible sound. The frequency of audible range is 20 Hz to 20 kHz. The frequency of ultrasonic waves more than 20 kHz. In piezoelectric effect, we use X-cut quartz crystal. Y-cut quartz crystals are generate shear waves. The natural frequency of piezoelectric oscillator F is equal to 1 by 2 pi 1 by 2t y by rho, where t is the thickness of the quartz crystal, y is Young modulus, rho is the density of the quartz crystal. Now, by using piezoelectric effect, we can generate the frequency as high as 500 megahertz. By using magnetostriction method, generation of frequencies beyond 300 kilohertz is not possible. In piezoelectric oscillator, used principle is converse of piezoelectric effect. When the magnetic field is applied on ferromagnetic material, the change of length is called magnetostriction effect. The field applied on electrical axis, then vibration of crystal in mechanical axis is called converse of piezoelectric effect. The pressure applied on mechanical axis, then potential difference developed across the electrical axis is called piezoelectric effect. Kuhn's method used to detect the ultrasonic waves. And one more bit is non-destructive test, which are used to find the faults in a materials, and in this process we are using the ultrasonic waves. Okay, all the best for the examination. Thank you.